Welcome to chemistry class. We are in session 4 of the chapter gaseous state. In this session, let us understand the concept of Dalton's law of partial pressures. Let's understand this Dalton's law of partial pressures. Suppose I take certain amount of ammonia in a vessel and let its pressure be Pa. Then in another vessel of same volume under the same conditions of temperature, let me take hydrogen chloride gas and let its pressure be Pb. Now, when both of these gases are transferred into another vessel of same volume by maintaining the same temperature, now tell me what will be the pressure in this particular vessel. Yes, what will be your answer? Is it making any sense of calculating the pressure in the final vessel? Definitely no. Why no? Because whenever ammonia and hydrogen chloride in the gaseous form, whenever they are combining, that results in the formation of a white colored ammonium chloride solid. As there is no gas in this vessel, it is meaningless to calculate the pressure in this particular vessel, isn't it? But if we have nitrogen in one vessel, let its pressure be Px, and let me take oxygen in another vessel of same volume at the same temperature and let the pressure here be Py. Now when both this nitrogen and oxygen are transferred into another vessel of the same volume at the same temperature, now what will be the pressure in this vessel? Yes, what will be your answer? First tell me whether we can calculate pressure for this or not. Definitely yes, because here nitrogen and oxygen are two gases which are not reacting with each other under the normal temperature. So in this vessel also nitrogen exerts some pressure and separately oxygen also exerts some pressure, isn't it? So what will be the pressure of this mixture of gases in this vessel? It is nothing but equal to the total pressure exerted by both these gases separately. That is Px plus Py will become equal to the total pressure of this gaseous mixture. And this pressure exerted by each and every individual gas, here it is Px and here it is Py, that we call it as the partial pressure. What is partial pressure? The pressure exerted by the individual gas of a gaseous mixture which occupies the same vessel as that occupied by the mixture earlier at the same temperature. So this is a vessel which contains the mixture of nitrogen and oxygen. Both of them together, whatever pressure they are exerting, that becomes the total pressure of the gaseous mixture. And the meaning of partial pressure is what is the pressure exerted by the nitrogen alone when it is present in this same vessel which was earlier occupied by gaseous mixture. That becomes the partial pressure of nitrogen. Similarly, what is the pressure exerted by the oxygen when it is present alone in the same vessel which was earlier occupied by the mixture, and that becomes the partial pressure of oxygen. So when we add the partial pressure of nitrogen and partial pressure of oxygen, we will be getting the total pressure of the gaseous mixture, and that is nothing but the Dalton's law of partial pressures. And it states that at a given temperature, the total pressure exerted by two or more non-reacting gases occupying a definite volume is equal to the sum of the partial pressures of the component gases. So here itself it's very clear that this Dalton's law is not applicable for a mixture of reacting gases, isn't it? In this case of ammonia and hydrogen chloride taken in gaseous form, whenever they are taken in the same vessel, they react with each other in order to form a solid compound. So whenever there is no gas at all, it is meaningless to calculate the pressure. So that is the reason why Dalton's law is not applicable for a mixture of reacting gases. It means that it is applicable only for the mixture of non-reacting gases. So what is the Dalton's law? At a given temperature, the total pressure exerted by a mixture of non-reacting gases is equal to the sum of their partial pressures. For example, there are two gases A and B in a vessel, and if Pa and Pb are their partial pressures, so according to Dalton's law, the total pressure of this gaseous mixture which contains these two non-reacting gases is equal to Pa plus Pb. Similarly, when we have a mixture of three gases A, B and C which are non-reacting with each other, and if PA, PB and PC are the individual partial pressures, then according to Dalton's law, the total pressure of this non-reacting gaseous mixture is equal to sum of their individual partial pressures, means equal to PA plus PB plus PC. Let's take a clear example. Here hydrogen is taken in a vessel where its pressure is equal to 50 mm. Let us take oxygen in another vessel of same volume and let its pressure be equal to 100 mm. So we have hydrogen and oxygen separately in two different vessels of same volume at the same temperature, and these are their individual pressures. Now when these two are mixed in the same vessel of same volume at the same temperature, and the total pressure of this gaseous mixture is equal to 50 plus 100, so it becomes equal to 150 mm. So what is Dalton's law? The total pressure exerted by a mixture of two or more non-reacting gases is equal to sum of their individual partial pressures. So it is 50 plus 100, which is equal to 150 mm. And that is about the concept of Dalton's law of partial pressures.